Zombie Apocalypse.
Okay, so this time we will try to discuss double integration method applied on a prop beam, which is a type of statically indeterminate beam. So let's get ready to be neurorized. Okay, suppose that we have this type of beam. So we are to compute the following given the inertia and the modulus of elasticity. So we have to find the reactions of the beam, slope at point D, and the maximum deflection. So this is a prop beam because we have a fixed support at A and we have a roller support at D. So what makes a beam to be called prop beam is if one of the supports, okay, is fixed and the other support is hinged or a roller. So let's try to analyze, no, how do we solve this kind of problem. Okay, so this will be our figure of analysis. So tingnan natin kung ano ba yung degree of statical indeterminacy na isang tinatawag natin prop beam. So reactions are 4 because we have 3 reactions on the hinge, on the fix, and one reaction on the roller support. So making it 4, and the members to be analyzed is only 1. So 4 minus 3 times 1 is equal to first degree. Likewise, if we have hinge support to replace the roller support, so there are 2 reactions to be specific on a hinge, and the sum of the reactions is 5. Okay, so n is also equal to 1, and 4 minus, I don't know, it's 5, sorry, it's 5, okay? Then, burahin natin para malinaw. So, it's 5 minus 3 times 1, it's second degree. So, regardless, we are going to use double integration method to calculate, no, kung ano ang mga pwede natin mahanap using double integration method. Okay? Now, if you will notice, under this type, we have to assume the reaction. So, ito yung pinaka-importante ng isang statical computation. Okay? I have assumed that my shear at A is going up. Then, it's up to you, no, kung gusto nyo i-assume ang moment at A as counterclockwise or clockwise. But most likely, by the virtue of the loading, it will become a moment of counterclockwise to resist the possible bending that the beam will produce. Now, the very important property of a fixed support now, again, it does not allow deflection unless the supports are yielding or moving. So, by this case, it would be drawn like this. So, at point A, so it will not deflect until such a position that will make it bend like that, and then of course as it reaches D, okay, with a tangent line to be formulated and drawn on point D. So this is how the beam will possibly deflect. So notice that at the support fix, so we are not going to allow deflection and rotation. So in this case, so we will try to set that y and y prime, no, for fixed support are both 0. Now to have some review, if this is hinge, no, hinge and roller, or pwede natin tawagin rocker support. So the only thing that we can identify is y equals 0 because of the deflection. Unless we are going to consider yielding conditions, so one of our template of analysis here. No? So this is assuming, and by default, walang binigay, that the support are not yielding or non-yielding supports, not moving in short. Okay? So we have to carry this idea whenever we have fixed support. Okay? So again, the rule of DIM, no? Ulitin natin, yung pinakadulong kaliwa, siya yung gagawin 0, 0 coordinates at point A, it will become 0, 0. While at B, it will become 2, 0, assuming no deflection muna, stationary position. Point C is it's 6, 0. And at point D is 11, 0, assuming no yielding. So notice that, again, by the rule of double integration method, we have to pass the cutting plane at the very last segment found on the rightmost segment. So here, at segment CD, as you pass the cutting plane here, and then notice that there will be a load, no, na matatamaan, which is this triangular load. it seems that this is decreasing. And you have to answer two types of question, no? Number one question, does the load touches the cutting plane? If not, you have to do a thing that's what we call geometrical reorientation. Or sa Tagalog, ito tawag nating dagdag bawas na area. And another critical question that you have to answer yes, but if not, then you have to do away again. Knowing that the load is touching now the cutting plane, the question would be, higher than 0 degree, is it increasingly touching the plane? So by this case, notice that the load is decreasing in nature. Pababa na pababa yung kanyang value. From tip 3.5 until such time 0 yung value niya until it reaches point D. So meaning we have violated the second rule. So what do? We need to perform reorientation of the section. How do we do it? So you have to do the following. Okay, so for reorientation, notice that what I did is, kinontinue ko muna as a common slope. Okay? And notice that there is a missing area here, no? Kung kukulayan ko yan, okay, ng other colors like violet, see? This one. Meron ka makikita dito na triangle in portion. At yan yung ilalagay natin sa baba in equivalent value. Okay? So, by that, we can now calculate, no? So, sabihin, kung ano man yung value nito tinamaan sa function of x, ito yung tatawagin natin distance of y. So, likewise, this will be a distance of y. So, ang magiging mangyari dito sa figure natin is, magiging buong rectangle na lang yung nasa taas na pababa ang nature. At dahil meron ka na dagdag na area na hindi mo na i-consider sa taas, so yung ilalagay natin sa baba ng nature is pataas. So, statically, they will be the same. Okay, likewise for the deflection property. Kasi the rule is, it doesn't offer na kapag wala kang load, deflection mo is nawawala din. Likewise, it doesn't offer na ang load natin is gradually decreasing, yung deflection din natin nagdi-decrease, no? It's just only show that the moment is a function of force and distance, so pwedeng lumaki, pwedeng lumiit. So, dapat you have to follow that rule, no, in using DIM and so the other methods after double integration method. So, it is very applicable to the methods right after this topic. So, therefore, that there will be new illustration like this. So, sa taas, magiging itsurang rectangle na lang siya with a similar value 3.5 kasi pag kinontinue mo yung slope, okay, same value. While other value, the green colored area, yung triangle, okay, that will be our load that goes up para masustain natin yung statical equivalent sila. Okay? Now, to continue, kapag zoom in natin ito yung lalabas. So, that is a function of y, a distance of x minus x as we proceed with the deliberation of the distances. So, there's a way that we need to use this one. And how to use this one? You have first to do the elucidation of the moment equation. Now, performing the moment equation at the cutting plane, so shear A times x, of course, as I assume it upward, and I assume moment at A as counterclockwise, so it is a negative bending. But don't forget that it's up to you. Naso nyo maglagay pa ba ng x raised to 0, since x raised to 0 is just only 1, or it can serve as a reminder that there is a distance of x. Kasi it was discussed in my past video lecture that a moment can also have a distance as we progress it with the calculation of slope and deflection. So, na-discuss ko na kompleto yan, but if you miss it out, I observe, as I observe, no, you have to view it in my video lecture, no, as considered in my playlist. So, you can review it again. No, I discussed it already. So, again, by rewriting all the equations, considering the 52 kilonewton rotating counter, this one, okay? Also, the load that goes up is the positive orientation of this load, which provide this equation. So therefore, it is the 1/2 of y x minus 6, then the 1/3 of x minus 6 kasi ang cutting plane natin yung centroid natin papupuntahin natin sa cutting plane, and then of course minus 3.5 yung rectangular road drawn in color blue. So, centroid of 1/2, syempre, the rule of the rectangle. Now, we need to derive a function of y because we cannot integrate this, no, if there is more than two variable, which is y and x. So, it should be a function of x because we are integrating as a function of a distance x. So, yung x kasi yung pinaka-moving distance natin dyan. Now, using similar triangle, so y as to x minus 6 equals 3.5 as to 5 as drawn. Kasi pag kinontinue natin ito, this is also 3.5, ano? Obviously, check here, pag kinontinue din natin yan, pag pinagsabay natin. So, therefore, by that, we can now replace the full equation as a function of x, yung y natin, as 7 over 10, quantity x minus 6, I mean. Naglagay na ako ng pointed parenthesis para ma-denote natin na ito i-combine natin mamaya dito sa equation na to. So, therefore, it's now homogeneous in x minus x of that particular equation. Then, we are now ready to integrate this and further simplify the equation before the next procedure, order of integration. So, pag sinimplify natin yan, ito yung magiging EIY double prime natin. So, this is the moment equation. Okay, or the EI, yes, it is the moment equation. While, as you integrate it once, this is the reference source of the equation theta, where y prime represents theta. So, this is the equation after integration. And then, don't forget to include the arbitrary constant, C sub 1. And further integration, that we will get the deflection equation. So, as a function of C1x and C2. So, yan. Now, we need to eliminate the arbitrary constant C1 and C2. Again, same rule. We need to use the properties of the support. Now, notice that you need to start at the very leftmost part or the support nearest to the leftmost part para makita natin baka may mga value na 0. Just like this. So, at x is 0, of course, this is a 0, 0 coordinate. It is a function of a fixed support where it was discussed earlier that the support fixed support as settlement or deflection and slope is concerned, they are both 0. So therefore, as we proceed, setting at x is 0, y is 0, taking a look on the EIY equation because y is the function that we need to observe. And replacing x as 0, of course, 0 over 6 is 0. Oh, 0 na ito. Most likely, this is 0. So, kanina nakita nyo, para apat yung shear A, MA, C1 and C2. But is there a way for me to eliminate arbitrary constant without getting involved the shears and moments? Yes. So, therefore, again, to continue, if x is 0, then 0 minus 2 inside the pointed parenthesis is 0. And 0 cube is 0. Don't forget that. So, pag may pointed parenthesis, pag negative or 0 yung loob, automatic 0 na siya. Pag positive, then accept the value inside and then perform the root or the exponent of the equation. So, x minus 6, of course, 0 din yan kasi 0 yung x natin. 0 minus 6 is negative 6. This is also 0. And of course, this is 0. So therefore, we can conclude that C2 equals 0 because EIY is also 0. So that's why C2 is 0. Again, wag muna kayo lumayo doon sa property ng fixed support kasi dalawa yung property niya, pati yung slope niya 0. So ito na po yung titingnan natin, yung EIY prime. No, ito, yan. Okay, yung binilugan natin na yan. Okay. So that's why as we continue, so again, making all these variables 0. So if you'll notice, this is 0. X is 0, 0 minus 2 is 0, x minus 6 is 0, 0 minus 6 is 0, and of course, C1 is 0. So, ito po yung nangyayari na C1 and C2 is 0 kapag ang fixed support natin ay nasa kaliwa. Pero kapag ang fixed support natin is nasa kanan, at sabihin natin, ito yung ating orientation. So, kung babalik rin natin, so you will not expect that C1 and C2 will be 0. So, it's either one of them or both of them has value. So, it doesn't matter. You don't have to memorize this thing. You just use the property of the support. And then you may encounter one equation, one support type kasi may moment ka naman dito. Or maybe you can use the other way around. So, you can use this evaluation as a purpose, no? So, ulitin ko, pag nagsiset, kailangan simulan nyo lagi sa leftmost part. So, dito magsimula. So, at x is 0 ka, then y is 0. Kasi at x is, kaya dulo pa rin yan, is 11, ang y at ang y prime niya is 0. So, dito pala sa una, makukompute mo na yung reaction at the roller support, yung R. Okay? And then followed by the C1 and the C2. Parang ganyan mangyari. So, of course, you need to validate, no? Actually, hindi pala yan una makukuha mo because may C1, C2 unknown ka pala. Magkakaroon ka ng 3 equations, 3 unknown. So for you to get that, you have to use also the set for three equations. So notice that we have three equations, okay? We have three unknowns. Then you can now compute the unknown. Okay? So you can get now the shear on the other side, the moment on the other side. So, three equations 3 unknown pagka inorient mo sa kanan. Pinaikot natin. Pero pag yung diniscuss natin ngayon na orientation, then you can compute for C1 and C2 are both to be 0. Okay? Now, as we proceed, of course, eliminated na, no, yung value na C1 and C2. So, next thing to do is to get the value of the shear in MA kasi you cannot compute the deflection and as well as the moment and no, the moment and the slope kapag may value shear in MA natin, no? So, there should be a value before computation. So, next is to investigate further yung another support at point D. Tingnan natin to, yung support at D, which is a roller support. Again, the property of the roller support, deflection is 0, and the moment on the point of hinge roller are also 0. So, as we continue, setting at x is equal to 11, y is 0, because that is the point of roller. We are not having deflection unless the support is yielding or given by the problem, or maybe it is a spring. So, that's the case. So, that will be one of my content. What if the support is a spring? Now, let's continue. Now, supplying at x is 11, notice that at EIY equation, all equations will be used, no, and will activate because all of the values like 11 minus 2, 11 minus 6, 11 minus 6 are all positive. And don't forget that C1 and C2 are already 0. So, you can now have your first equation. Also, at x is 11, EIY double prime is 0. Y is 0. Wala ka kasing overhang dito na magke-create pa ng bending on that support. So, the moment at point D, dahil wala kang overhang load dyan or moment na umikot dyan, so EIY double prime is 0. So, therefore, at x is 11, so replacing x, so titingnan ka sa first equation natin dito. So, para ka nag-statics na lang dyan, in short, so then you can have your second set of equation. Now, using two equations to unknown, then you will get the following. Now, notice that both of the answers for shear and MA are positive, and according to the rule of statics, then your assumption is correct. So, therefore, my assumption for shear A is correct, upward, and my assumption is correct for moment at A to be counterclockwise. Usually kasi sa mga fixed support natin, basta pag may gravity load tayo, ang nature kasi ng kanilang mga reaction, sabihin na natin na itong side lang na to is pa ganito, no, pa counterclockwise. So, kahit ilipat natin sa kabila is pa kabila kasi there should be an equivalent counter resistance. So, yung bending kasi dito, that will be the most evident thing to look at. So, therefore, talagang gaya expectation. But of course, kung di kayo sanay, you can assume it as a clockwise and then perform the calculation piece. You will be corrected anyway. So, therefore, as I get the shear A and MA, then ito din gagamitin natin mamaya sa value of shear A, no? At saka MA. Okay? So, ganun din dito, tsaka dito. Then we now continue with the question of the answers now. So, therefore, the question is the reaction of the beam. So, may nakuha na tayo actually. So, computing also for the reaction at D. So, therefore, performing EFY na lang. So, I equate upward equals downward. So, static yan. O pwede nyo equate na lang sa 0. Positive upward, negative downward. So, you get the same. So, R sub D is 7.3593 kilonewton. So, those are the answers for the reactions of the beam. So, don't forget that whenever you provide answers for the reaction, you have to supply the value, the unit, and the direction. It's very important. Okay, so knowing those of the reaction, now we compute for the slope at point D. And point D is located at x is 11. Kasi, tandaan natin na ang final deflection niya, for these such cases, or you can find it out naman kapag titignan natin individually yung mga points of deflection tsaka slopes, no, at x is an increment of 1. You can draw your own slope deflection curve here. So therefore, as my discussion here, again, the deflection at support A, which is fixed, kailan wala, 0, and then suddenly bababa, and then kakana slope sa D. So, we need to identify this. So, by this figure, we will try to have an idea that the slope at D will be located on the first and the third. No? If we are aware of the first, the second, the third, and the fourth quadrant, as Rene Descartes' rule of this figure analysis, then we will try to prove using DIM, since DIM is following the rule of Rene Descartes' diagram. So therefore, at axis 11, y prime is theta d. Notice that we got, no, by replacing all the values by axis 11 at EIY prime equation, and note that C1, C2 is 0. So the sign is positive. So therefore, it resembles only a positive quadrant, a positive tangent. Kasi, di ba, positive, positive, negative, negative, and positive over positive is positive, negative over negative is positive. So therefore, the location is on the first or the third quadrant, which is the validation has been produced. So therefore, by using the respective EI, no? So by conversion, again, we need to convert the 78.00995 kilonewton square meter into a Newton cubic millimeter to satisfy the unit of your denominator, which is I'm converting it in terms of megapascal unit also in Newton and millimeter units. That's why there is a 1000 cube multiplier beside. Converting kilonewton to Newton is 1000. Converting square meter to square cubic millimeter, no? Square millimeter is 1000 squared. So meaning 1000 times 1000 squared is 1000 cube. Again, 110 is converted into a megapascal unit because we know that megapascal, 1 megapascal is equal to 1 Newton per cubic per square millimeter. Okay? So therefore, by that, we will now have a slope at D as 2.0449 times 10 to the negative 4 radians located on the first and the third quadrant. So that proves our discussion on this. Now, we move on to the identification of the maximum deflection. So it's very important to know that at y is deflection maximum, the slope is always 0, the maxima minima condition as discussed by calculus. So I will assume that the learners or viewers of this video lecture are calculating this also. Ito mga na-discuss natin for this video lecture so that you can identify if the answers are correctly calculated. Okay? So therefore, there's a question now, where is x? So kanina, di ba, nagdrawing tayo ng deflection diagram. So, nasaan kaya dyan? Will it be on point BC? Will it be on CD? It's up to the type of the load that was being applied. So, mag-assume tayo. So, if I were to assume at BC, so, limiting distance niya, no, is from 2 to 6. Kung ang 0, 0 coordinate mo is from the leftmost, which is the default case in my discussion to the integration method. So, it is from 2 to 6. And then, finally, the technique that we're going to use or the principle is to use the 6 or the upper boundary. Lagi upper boundary is i-try nyo i-assume na ipasok sa lahat ng equation ng x sa EIY prime. So therefore, 6 minus 2 is positive, 6 minus 6 is 0, 6 minus 6 is 0. Why? Bakit ginagamit yung pinakamalaking boundary? Kasi yung value natin, hindi naman sasaktong pinakamalaking boundary. It will be lower than, kaya nga less than or equal eh. It can be 5.5, it can be 5, it can be 4, but it can be more than 2. It should be more than 2 or equal to 2. Okay? So therefore, kapag nag-subtract ka, 4.82 minus 6, 0 na yan. Kasi 4.82 minus 6 is a negative value. Pero kung titignan nyo yung x minus 2, ito, so, kahit ano i-apply natin, between 2 to 6, magiging positive yan unless exactly x is 2. Otherwise, you need to recalculate. However, hindi yata sasakto ito. Mihira ang sumasakto ng 2. So, let us place our bet that it is in between 2 to 6. Not exactly 2, not exactly 6. So, therefore, by that, you will notice the equation that will only activate is the shear A, MA. Okay? Shear A, MA, and the x minus 2. Kasi 6 minus 2 is positive eh. So, yun ang technique na lang natin dyan. So, kaya ito yung naging equation natin. And then, you will get two values using algebra. Okay? We will get negative 25.7531, which is we cannot accept. But, if the value is 5.8076, then, it is okay. Why? Because it is in between 2 to 6. So, just like before our discussion, what if nagkamali ka na assumption? Isa sa mga root, bibigyan ka niya ng idea kung saan span. For example, if I get it wrong, at binigyan niya ako na 7.5122. So, this value, it seems wrong from 2 to 6, pero nasa segment CD siya because segment CD is running from 6 to 11. And then, you have to recalculate based on this new finding na nandun yung sa isang span. Isang segment, I mean. Pero, it doesn't offer same value, the 7.5122. Magbabago pa yan due to reiteration. Maaaring napakalit ng pagbabago, or minsan dito pala, nagkakaroon ng pagbabago, or minsan mismo sa buo na yan, nagbabago. You have to recalculate everything again. Okay, by this, since sumama, then we can now proceed. At x is 5.8076, then we can now get the deflection maximum. So by this, replacing at x is 5.8076, so using EIY, so ito yung magkakaroon, shear A times x cube over 6, minus MA of x squared over 2, tsaka minus 26 over 3 x minus 2 cube. Again, ito manatitira na to, you don't have to consider na kasi it is less than 6. So magni-negative yan. Okay? So by this, we can now get negative 255.3653 kilonewton cubic meter. Ang unit po ng delta maximum EI. So negative means a downward deflection. Again, using René Descartes rule, upward ang positive, negative naman yung y natin pagpababa. So therefore, it deflects downward. Okay? So therefore, the answer would be, again, by conversion, making it Newton millimeter, kaya nagkaroon ng 1,000 to the fourth. Conversion kasi ng kilonewton to Newton, and conversion of cubic meter, to cubic millimeter. So 1,000 times 1,000 cube is 1,000 to the fourth. So, ganun din conversion natin sa baba. Ginawa natin siyang megapascal unit, Newton and millimeter. So, by this, we will get 0.6694 millimeter that goes down. So, ito yung pinakamalaking deflection na makakompute natin within the span. So, it should not be lower than any value. And then, you can try to find any value of deflection at a given x, let's say 1, at x is 2, at x is 2.5, you can try to find it out, and then no value will be higher than this. So this would be the answer for our maximum deflection, and this is my discussion to the viewers or to the learners who want to understand double integration method applied on a prop beam. Again, so thanks for viewing. I hope you learned something new today. So please subscribe to this YouTube channel, so Neuros Engineering Online. And as our tradition goes, you have been Neurorized, and see you in our next video lecture. So coming right up to this is the application of double integration method using other types of indeterminate beam. So we will try to understand new behavior of supports.